Hi there, let's try to do today this another Leetcode problem. This is Leetcode 146 and it talks about LRU cache. So basically what's an LRU cache? LRU cache is a data structure. You know what is a cache is? Usually the cache is something that we use in computer architecture to speed things up between the CPU and the main memory. So the thing is that the idea behind cache is there's something called locality of reference, and they have like temporal locality and the spatial locality. And then what happens is the idea is that the recently used items will be used again. So rather than having to go to main memory all the time, the CPUs usually have this layer 1 and layer 2 caches. So that's the idea behind cache. And because caches have very small fast memory next to CPU, they usually try to keep the items that are most used rather than the least used, because and they keep basically updating it so that you will have items that are most recently used in the cache. So here what the problem is talking about is saying that design and implement a data structure for least recently used cache. It should support the following operations: get and put. What does get do? Get the value, and it says it will always be positive of the key if the key exists in the cache, otherwise return -1. Put takes two arguments, key and value, and it says set or insert the value if the key is not already present. When the cache reached its capacity, it should invalidate the least recently used item before inserting a new item. So basically, it's a very simple LRU cache. It only supports two operations, get and put. And get is basically given an argument key and it returns the value if the key exists in the cache, otherwise it will return -1. And put will take two arguments, key and value, set or insert the value if the key is not already present. When the cache reaches its capacity, it should invalidate the least recently used item before inserting a new item. So basically flush the cache of the items that have not been used and always keep the most recently used items first in the cache. And it says the cache is initialized with a positive capacity. Now, could you do both operations in O1 time complexity? It says so. O1 time complexity, I think we talked about this in previous video. O1 basically means it's a constant, so it means fix it, and basically saying that the result should not be dependent on the length of the input. So whether you give it a 10,000 items or 10 million items, you should always take constant time. So that's what it's saying, that you should do this in O1 time complexity. And then it's saying, it actually gives some examples here. So let's see what are the examples. This has the first line here is the constructor. Basically he's using the LRU cache class object constructor and passing a argument of 2. So this cache is basically initialized with a capacity of 2, and then we do a put of key 1 value 1, then we do a put of key 2 value 2. So now the cache is full. What happens at this point? We try to get a value uh, of the key 1, which means that not only we return the value 1, we also have to internally make sure that the cache is updated in such a way that 1 becomes the most recently used item, or we have to make sure that the 1 goes to the whatever data structure we use. We have to make sure that the 1 is at the top of it. And in this case, what would happen is, even though you would think that 2 was put last and 2 would have been the most recently used item, but because we access 1, 1 becomes the most recently used item. Now at this point, when we put cache.put 3, key 3 and value 3, because the 2 is the least recently used item at this point, that is the one that is flushed, and then your cache would actually look like 1133, assuming that, or in our case it would actually look like, if we are going from right to left, if we are keeping the most recently used item in the right, then it would look like 33, depending upon how you read it. If you read it from left, then it will be 1133, because the 2 is flushed out. Now we try to get 2, and as we know, the 2 has been flushed out, the key 2 has been flushed out, so we get a value of -1. Now we try to put a value 44, key value 44, and as you know, the cache is probably looking like 1133, so it would start to look like 3344, and 11 is flushed out. So that's the idea, and then you get because 1 is already flushed out, here you should get -1, and then you get 3, which is 3, and this get 4. So let's see how to implement this in software. So what I plan to do is to use a data structure in Python known as ordered dictionary. And the difference between ordered dictionary and the regular dictionary is that, for example, a regular dictionary might be initialized with something like this in Python, whereas a ordered dictionary would be initialized something like, you will be calling the ordered dict constructor, and usually, they are in this package collections. So I wonder if I think this Leetcode already has all these packages included, so we don't have to do that. So let's go right into the implementation, and what we plan to do is we'll use ordered dict, and I think it should be pretty straightforward to implement this. So let's go to the ordered dict. Now, so what we'll do is we'll take this from here. So let's try to implement the constructor first. So here we are. We will say we will initialize a object instance variable OD, which is the ordered dict, and we would say that the capacity, we will maintain the size of the LRU cache and initialize that with capacity. So now let's see that how we're going to do so the constructor is done. Now let's try to implement get method. So the get method would start by looking for the result. We will try to see that whether that value exists in the dictionary or not. And how do we do that? We basically try to see. So let's try to do that. So if OD, so what we do is we say result equal to, let's see, OD and key here. So, or you know what, this is not the way it is done in Python. In Python you usually do like, if key in OD, then we say result. This is very Pythonic, by the way, that's what they call it. You don't say things like if key in if od dot has items and all. I think has items, there used to be a function known as has key, or I think has item, I think has key, which has been, I think, deprecated or removed entirely in Python 3. And this key using the operator in operator is considered very Pythonic. So let's use that. If key in od, we say result equal to od self dot od key. And now that's not enough, just to return the result. We also have to use the properties of the ordered dictionary to make sure that we update the dictionary in such a way that the key ends up being the most recently used item. So how do we do that? So just to explain to you a little bit, the plan here is that our ordered dictionary would look something like the rightmost item would have, it always inserts at the rightmost side. And so what we can do is we can delete this key, we can delete this key, and then we can insert it again. And the result of inserting will be that it will end up being the most recently used item because of the property of the ordered dictionary. That's the point. Now you see what happens. So it doesn't matter where in the ordered dictionary this key was, but when we delete it and then we reinsert it, at this point at line 12 it ended up being the most recently used item. And in the ordered dictionary, if you're going from left to right, it will end up being the rightmost item. So that is good, that is looking good. And we can say here return result, or if the key is not fine, as the API that we have to implement is asking us to return -1, so we say return -1. So that's how we can code get function or get method of the LRU cache. Now let's see if there is a problem here. Could we optimize this a little bit, this code? I mean, one way to write this code could also be that we initialize result equal to -1. And now if key in D, if key in ordered dictionary here at line 10, everything is looking good. And if we fall here, we just say return result. So the result would either be the value of the key that we are looking for, or if the key is not in OD ordered dictionary, we would just basically fall here at line 15 and then we will return result. But I think intuitively and the way our thought process worked, it seems to me that the earlier method looked better, where we can immediately see, oh, I see, that's what is going on here. But nevertheless, let's have it the way it is, and then let's try to implement the put method. How can we implement the put method? So the put method you basically implement by the similar techniques of the ordered dictionary, making sure that if we so let's see that we can probably write some comment here. Let's see. So we say that insert or update a key in the ordered dictionary if the making sure it becomes the most recently used item. Also, if we cross, or if we find that if we go over the limit, the capacity of the we go over the capacity of the dictionary. We need to trim or remove the least recently used items, which would be, in our case, as we know, as I just said, this is the ordered dictionary, so the insertions will always happen on the right side and the least recently used items will be on the left side. So having said that, let's try to implement that. So let's do that. So how do we go about inserting or updating a key in the ordered dictionary? So if key, so let's start by having a variable on insert which is equal to false. Now if key in od, sorry, self.od, now I think that tells us that we need to fix here as well, because in Python, when you're working on an object, you have to refer to the object instance variable, and that's why you have to keep saying self dot the instance variable. So if key in self dot od, that means this is update case. We can write here update case, and in that case what we do, all we do is we basically delete self.od.key and then we again insert, and this will end up this being the most recently used item. So self.od key equal to the value, and we couldn't care what the previous value was because this is an update case and we don't have to return anything. So this is all looking good, and we just else, so delete update case is you basically delete the existing key and you basically again reinsert the key with the value that is a new value, and it will end up being the most recently used. Else, this is a insert case, insert a new key. In this case what would happen is we will say self.od key equal to value, and we will say insert equal to true. Now let's come here, and at this point what happens is we try to see if insert is true. If insert and, this is the Python's way of using logical operators, unlike C where you might have said something like and or, here you actually do and or, but in this case we need to do an and, because if it is insert and the length of the OD, because we might go over the capacity, and length self OD is greater than self dot size, then we need to delete items from the ordered dictionary. So how do we do that? We say self.od.pop item. Now the pop item always removes the item that was inserted on its right hand. This is the last added item, but we don't want that because in our case the most recently used items are on the right side, so we want to actually insert items on the left side. And how do we do that? We say last equal to false. Okay, so that's the implementation. Hopefully it works. We can try to see if it works. So let's do a run code. Let's see that. Awesome, it actually is accepted, which I was thinking it's not going to be the case. I was of the opinion that there might be some error somewhere, but apparently it worked first time, and this is very good news for us. So now let's try to see if summation also works, because they have more test cases, Wow, awesome. So basically it did work, and it's faster than 53% of Python 3 online submissions for LRU cache. So there you have it, guys. We just implemented LRU cache using Python's ordered dictionary, and it seemed pretty straightforward. I mean, unless you have some problems with the ordered dictionary beneath and what kind of um, space and time constraints they have, so time complexity. So we were asked to do this in O1, and these are pretty much, that seems to be the case. Now there's another way to go about doing this, which is you don't use the ordered dictionary, you actually use the normal dictionary in Python, and then you keep track of the order by using a doubly linked list, and we might do that video next time. But until then, adieu, have a good time coding, see you next time.